Algebra 1, Section 2-3. I am going to do all of the examples here, but I am going to go quickly. So pay attention and or pause as you need to process what I'm about to say. When we multiply a negative times a negative, that's going to be positive. You probably already knew that. So negative times a negative is positive. 3 times 11 is 33. Looking at this one, this is negative 6 times 3/4. In both of these examples, the multiplication is being modeled by parentheses. You should know that. That's just a common way that we do things in Algebra 1. Sometimes we use the times dot. I believe I talked in a previous video about not using the times symbol, that anymore. Times dot is appropriate, but often it's just a number in front of or behind parentheses, and we need to know that that's multiplication. Now, the way I like to do this problem is negative 6 is like saying negative 6 over 1, and treat it as it truly is, a fraction multiplying problem. So negative 6 times 3 would be negative 18. 1 times 4 would be 4. Remember, we multiply the tops and then we multiply the bottoms. That's numerators and denominators. And then this fraction does need to be reduced, and it's negative 9 over 2. Again, you could say negative 4.5. That would be correct. Please don't say negative 4.5, though, because that is a decimal. They gave us a fraction problem. We should produce a fraction answer. Second example says to evaluate, and we have 5rs, where r is negative 18 and s is negative 5. And I think that's going to be 450. Now that might be on the fringe as far as mental math, but everybody should see positive, negative, negative. As we multiply a positive by a negative, that's going to be positive. I know that 5 times 18 is 90. So that 90 times 5 is 450. The answer is positive 450. This says use the expression you can see there to calculate the change in temperature for an increase in altitude A of 7,200 feet. The A is in the formula, and it's 7,200 feet. So negative 5.5 times 7,200, that's 7,200. Sorry for the lazy language. Over 1,000. Now, certainly we should reduce this fraction first. When you divide something by 10, that moves the decimal one place. If you divide something by 100, it moves it 2 places. We're dividing by 1,000, so really this is 7.2. I talked in a previous example about don't give me decimal. Well, this is a decimal problem, right? So it's not that we don't like decimal or are afraid of decimal or are trying to shun decimal. We love decimal. And in this case, we should use it. And now would be reasonable to grab your calculator. This is not something I would expect you to be able to multiply on your own. I would think that you could do it if you used some paper, but why do we have you with the calculator in the first place if you have to multiply things by hand? So assuming you still have that skill, grab your calculator, multiply negative 5.5 by 7.2, you'll get 39.6, negative 39.6. That's temperature, degrees Fahrenheit. Use orders of operation to simplify each expression. Very important concept to understand the difference between these two things. In some ways, it's better to say, rather than always saying negative, you can kind of think of this as like the opposite of. Negative means the opposite of, right? So when a number's already negative and then we add a negative to it, that's negative, negative, it becomes positive. Positive is the opposite of negative. This is saying the opposite of 0.2 to the fourth. So whatever 0.2 to the fourth is, we're going to take its opposite and make it negative. Okay? So 0.2 to the fourth, I believe, is 0.0016. But I might be off by a 0, so I'm going to use my calculator. No, I was right, 0.0016. So this is negative 0.0016. It's like saying the opposite of 0.2 times 0.2 times 0.2 times 0.2. That's 0.0016, and then we make it negative. As opposed to here, and if you think about what I just said about this, it's negative 0.2 times 0.2 times 0.2 times 0.2. This is really saying negative 0.2 times negative 0.2 times negative 0.2 times negative 0.2. That's a negative times a negative times a negative times a negative. That's going to be positive. This is 0.0016. The difference of the parentheses is saying take negative 0.2 and multiply it by itself 4 times, whereas Here, it's the opposite of 0.2 multiplied by itself, a total of 4 0.2s. And we get into division. This section is multiplying and dividing. We spent a section in addition, a section in subtraction, and now we're doing a section that covers the other two operations, multiplication and division. When you multiply two numbers and one of them is negative, the result is negative. When you multiply two numbers and they're both negative, the result is positive. Obviously, when they're both positive, they're positive, that result. Same rule when it comes to division. When I take 70 and I divide it by -5, my result is going to be negative. And then once I know that, I just need to divide 70 by 5. By the way, I like writing these in fraction form too, if you find that helpful. 70 divided by 5 would be 14. Here we have a negative divided by a negative. You could write it as -54/9. I just like the fractions. It's good training for you as we go into Algebra 1. Into the harder stuff, Algebra 1. I mean to put a negative there too, right? So it's -54 divided by -9. A negative divided by a negative is positive, and that one's going to be 6. 54 divided by 9 is 6, because you remember your times tables, and 6 times 9 is 54. Okay, here's an interesting evaluate problem. Let's just plug everything in as it states there. -x, which is 4, over y, which is -2, minus 4, times z squared, where z is -4. I'm putting it in parentheses because it's all of -4 that is getting plugged in for z here. That means -4 should be squared in orders of operation. -4 here is going to get squared. Okay, now let's simplify here and let's simplify here if we can. This is -4 over -2. That means negative is going to be positive. 4 over 2 is 2. Minus 4, and similar to the last problem, this -4 is being raised to an even power. That's going to be 16. -4 times -4 would be positive 16. And now we just need to subtract 2 minus 64, because 4 times 16 is 64. That would be -62. And one more. Let's deal with dividing fractions. You have p divided by r, p over r. It might be helpful in this case to actually do the opposite of what I was showing you earlier and actually write it as a division problem. Because, as you probably have heard before, when you divide something by a fraction, it really means multiply by the reciprocal. In fact, it doesn't have to be a fraction. The operation division means multiply by the reciprocal. It's just that that becomes very pertinent to a problem like this when we're dealing with fractions. So p is 3 over 2 divided by r, which is -3/4. Okay? Now, that means multiply by the reciprocal of. So what we want to do is change divide to times and flip the second fraction. A reciprocal is a number that you're given a number. It's the number that you can multiply it by in order to be 1. So just sidebar here, -3/4 times something to be equal to 1. Think about the sign. Won't this have to be negative? Negative times a negative is going to give you positive 1, and it's 4/3, right? Because this would then give you, again, negative times negative, which is positive. 3 times 4 would be 12 in the numerator, 3 times 4 would be 12 in the denominator, and 12/12 then would reduce to 1. So we're saying changing divide to times, and this here would be -4/3, the reciprocal of -3/4. Now, I didn't model this before, so let me kind of cover this right now. You could certainly multiply the numerators, multiply the denominators, and simplify the fraction. Someone probably is already doing it this way, so let me address it. I think this is a good way to do it, is to reduce first. 3/3 is going to reduce. 4 and 2 reduces to 2 over 1. That negative is still there. The one drawback to this is you can kind of lose track of what you're doing, so be careful if you're going to do it this way. But I kind of like reducing first, but I'm dealing with smaller numbers as I multiply. So 1 times 2 is 2, 1 times 1 is just 1, and it's going to be negative because we had a positive times a negative. So this is -2. Okay, and that's it. Thanks for watching.